These notes are for finding area on the coordinate plane. We're going to use the distance formula and the Pythagorean theorem to find area. This first section of notes is just the basic finding area of shapes, the area of a triangle, the area of a rectangle, using the Pythagorean theorem, and then of course the distance formula, and then how to do it for those three shapes. But what I want to be able to show you in this video is how to apply it to what we've been doing. So those will be completed notes for later, but I want you to see this part right now. So we are looking for the area of a rectangle. And I've given you the vertices. And I'm going to use the Pythagorean theorem to find the length of OP, which is right here. And then I'm going to find NO, both using the Pythagorean theorem. Now, because this is a rectangle, that means that these two sides are congruent and these two sides are congruent. So what I'm going to do is draw a little triangle right here, and then do the same thing for OP, so that now I can use the Pythagorean theorem to find those diagonals. So P has sides 1, 2, 3, 4. 1, 2, 3, 4. And NO has sides 2 and 2. So to find NO, that will be C squared equals 2 squared plus 2 squared. So C is the square root of 4 plus 4. C is the square root of 8, which I'm going to leave it that way because that'll give me, when I go to clean it all up and multiply, that'll give me the cleanest answer. So then we're going to find OP, and that says that C squared is 4 squared plus 4 squared. Remember that this is our right angle, so that's why we found C where we did. And so when I say C is the square root of 16 plus 16, so C is the square root of 32. So I can also do this using the distance formula. Remember that I'm looking for N, which is 1, 7, and O, which is negative 1, 5. So I can say that D is the square root of 1 minus 1 squared plus 7 minus 5 squared, which still gives me the square root of 8. And I can do the same thing for O and P, where P is 3, 1. Oops. Or I can say that D is the square root of 3 minus 1 squared plus 1 minus 5 squared, which still gives me the square root of 16. So I can use the distance formula or the Pythagorean theorem. It really becomes your choice when you have the proper set of circumstances. So then to find area is length times width. So that's the square root of 32 times the square root of 16, which comes out to 16 units. So you can see that's why we left it as radicals. It gives us cleaner answers. So I can use the Pythagorean theorem or the distance formula for that one. Now this next one is for a triangle. And it just has some different vocabulary that was discussed up earlier in the notes, but I want to make sure that we understand it. So I've got my my triangle with its vertices, and we're going to circumscribe a rectangle. That just means to draw a rectangle around my shape. So when I do that, I just want all of the vertices, all of the corners of the triangle to be touching the triangle. And so I'm going to find the area of the rectangle and then subtract out 1, 2, 3 triangles, and that will give me the piece that I'm looking for. So we have area rectangle minus the area of triangle 1 minus the area of triangle 2 minus the area of triangle 3. So let's get some figures here. So 3, 1, 2, 3, this is 5. This is 1, 2, 3, 4. This piece is 4. This piece is 2. This is 1. This is 1. So the rectangle is 3 times 15. The first triangle, the dimensions are 4 by 3. Remember, a triangle is half the base times the height, so that's half of the base, which is 3 times 4. The second triangle is 1 and 2, so that's half of 1 times 2. And the last triangle has 5 by 1, so that's half of 5 times 1. So then we just simplify all of that, and we get that that's 45 minus 6 minus 1 minus 2.5. And you could do this all in the calculator at once and get that that equals 5.5 units squared. So that 5.5 is the area of this triangle for which I don't have a perpendicular height. So that's how you find the height when it talks about circumscribing, by drawing rectangles and then subtracting them out. Okay?